are starting time and work problems. So time and work is very important topic for our exam, and we need to understand. We can understand this topic very easily. All the problems will crack down in a very easiest method. And I'm sure after watching this video, after understanding all the different types of the problem, all the types of time and work problem will be you can solve all the problems in less than a minute. I'm sure for that. So first we'll understand in this time and work problem, what are the different types of the problem they ask. So I have just categorized these problems. They are asking 10 different types of the problem. So type number 1 is the basic type problem, which is the very basic type. Second is what? Fraction of type problem, where they will give the part of the fraction and they will ask us to find out how much time it will. Third is what? Equation types of problem, where they will say that A and B together they can finish in that many days, and B and C together they will finish in that many days, and C and D they can finish in that many days, and then we need to find out A, B, C, D will finish in how many days. So we'll discuss this type 3 problem as well. Type 4 problems are very important, which we can say some part of work. So in this kind of the question, some part of the work is done by A and some part of the work is done by B. Now type 5 problem, which is we can say that efficiency type of problem, where we can say that that A is 20% more efficient than B. Then we need to find out that together they will finish in how many days. Type 6 is what? Alternate days type, like A is doing 1 day work and then B is doing another day work, and then how many days they will take to finish the work. And then various combinations are there. Then we have a salary type, which is very easy. Then type number 8 is what? Again, it's very important, that X boy, X man and Y boys type. They will give us 3 situations: situation 1, situation 2 and situation 3. We need to derive the answers of situation 3 by using the data from situation 1 and situation 2. Then type 9 problem is what? Unitary method, we can say that number of different man and different days type. And last is what? Very important again, that food remaining type, the food is there in the hostel for certain days, and then how many days they will take to consume the food. So these types of problems are there. In time and work, let's discuss type 1 problem, which is very simple, which we all know, the basic type problem. Suppose that A can finish a work in X days and B can finish a work in Y days. So we need to find out if together they will finish, so together how many days they will finish the work. So simple method of handle these kind of the problem is what? First we'll find out A's 1 day work, which will be 1 upon X, and B's 1 day work, which will be 1 upon Y, and then we'll add. So we will find out that together they will finish in 1 day how much work they are going to finish. So which will come 1 upon X plus 1 upon Y. After solving this, whatever number will come, if we are going to reciprocate that number, that will find out that we will get that how many days together they will finish the work. So let's understand the concept. So if A can finish a piece of work in X days and B completes the some work in Y days, then work done by A in 1 day is what? 1 upon X, and work done by B in 1 day is what? 1 upon Y. So together their 1 day work will be 1 upon X plus 1 upon Y. When we'll solve this, so we'll find out X plus Y upon XY. So time taken to complete the work A and B both is what? XY upon X plus Y. So here, but very important thing which we need to understand and which we need to remember and focus, that if negative work is there, so we, instead of plus, we will minus. Suppose that pipe A is filling the tank and pipe B is emptying the tank. So in that case, we need to use 1 upon A minus 1 upon B, or 1 upon X minus 1 upon Y. So if negative work is there, so definitely we need to minus. So let's understand by solving this basic type, by solving one problem. So let's say A can finish a work in 6 days and B can finish a work in 9 days. So together they will finish how many days? So let's understand the problem first. A can do a piece of work in 6 days and B in 9 days. How many days both take together to complete the work? So this is very simple question, like we can easily solve 1 upon 6 plus 1 upon 9. So let's see the solution. That according to a question, A can finish the whole work in 6 days. So A's 1 day work is what? 1 upon 6. Similarly, B's 1 day work is what? 1 upon 9. So we'll find out A and B's 1 day work, which will be 1 upon 6 plus 1 upon 9, When we'll solve this, so we'll take the LCM, which will come 54, and in the numerator 9 plus 6, so it will come 15 upon 4. So therefore we can write down A and B's can finish the whole work in 54 upon 15 days, which is 3.6 days. So this is the basic type of question which we can easily solve, and if A, B or C is there, so we can keep on adding, but make sure like if negative work is there, so we are subtracting that work. Thank you. So in time and work, type 2 problems are very easy, which is we can say fraction of work type. So suppose if I say if A can finish half work in 4 days, so total work he will finish in half work he is doing in 4 days, so total work he will finish in 8 days. Or if I say A can finish a work 3/4 of work in 30 days, so total work he will finish in what, 30 upon 3 by 4, which will come 40 days. So simple, like if A is doing M upon N part of work in D days, so total how many days A will finish? D upon N. So let's understand the concept. If A can finish M upon N part of work in D days, then total time taken to finish the whole work by A is equals to D divided by M upon N days. So if you are using this simple, like D upon divided by M upon N days, so we can easily find out that total time how many days A will alone take to finish the work. It's very simple. Let's solve one question. One inlet line fills an empty tank of 1/4 capacity in 8 hours, and a second inlet pipe fills the same empty tank to 7 upon 8 full in 14 hours while pumping at their respective constant rates. How many hours will it take both pipes pumping simultaneously at their respective constant rates to fill the empty tank to the capacity? So now we can see the question. It's very simple question, like we can easily say the part 1 and part 2, 2 pipes are there. So let's solve. So first pipe can fill 1 upon 4 of the tank in 8 hours. So total time how much it will take? 8 upon 1 upon 4, which is 32 hours. Similarly, 7 part of the second pipe can fill 7 upon 8 of the tank in 14 hours. So total time how much it will take? 14 upon 7 upon 8, which is 16 hours. So now we can easily solve that total. If both the pipes are open, then how much time it will take to fill the tank? So we can say 1 upon 32 plus 1 upon 60 when we'll solve. So LCM come 32 and 3 upon 32, which is 640 minutes. So now as answer is given in the hours and the minute concept, so we'll convert 640 minutes in the hours. So how we'll do? We'll divide by 60. So we'll get 60 is to 2 by 3. So 2 by 3 is what? 2 by 3 hours ko we'll convert in the minutes, which will come 40 minutes. So answer is what? 10 hours 40 minutes. So this is a very easy method. Like if we have D upon N, immediately we'll do. If we have ready everything, so we can easily solve, and quickly we can easily solve these kind of questions. In time and work, let's discuss type 3 problem, which we can say equation types of problems. So equation types of problems are, they will look lengthy, but if we'll solve properly, that it is very easy. Let's understand what kind of the problems are these. Let's understand the concept. If A and B can do a work in X days, B and C can do the same work in Y days, and C and A can do the same work in Z days. So how we'll solve this? So we simply will follow 4 steps and we can easily get the answer. So first we'll find out A and B's one-day work, B and C's one-day work, and A and C's one-day work. And then what we are going to do, if we are going to add all of them, all 3, then what we are going to get? We are going to get A, B and C's together's 2 days work. And then we'll get ABC's one-day work. So once we have the ABC one-day work, then we can reciprocate the figure, and then we take the reciprocal of that amount, and we'll get ABC together. They will take how much time they will take to finish the work. So if you are using these 4 steps, so it's these equation types problems are very easy. Let's solve one question. A and B can do a piece of work in 38 days. B and C can do it in 114 days. A and C can do in 228 days. In how many days A alone can finish the work? So as we can see that what we are going to do in this, we'll First we are going to add A and B's work, then B and C's work, and C and A's work, and then we are going to add all three equations. So we'll get A, B, C's one day work, and then we'll take the reciprocal of that figure. So we'll find out A, B, C together they will finish in how many days to finish the work. But here in this question they are asking that A alone will finish in how many days. So the fourth equation which will come that A, B, C's together work. So if we'll subtract B and C's work from that, so we'll find out A's one day work, and then we'll reciprocate the figure. So we'll find out A's one day work. So let's solve. So A and B's one day work is what? 1 upon 38. B and C's one day work is 1 upon 114. And A and C's one day work is what? 1 upon 228. So 2 days, basically 2 of ABC's one day work, like 2 days of ABC's 2 day work will be what? 1 upon 38 upon 1 upon 114 plus 1 upon 228, which will 9 upon 228. And if we'll find out ABC's one day work, so which will come 9 upon 554. From this, if we are going to minus A and B's one day work, so we'll get A's alone can finish like A's one day work. So 9 upon 456 minus 114 is equals to 5 upon 556. So we can find out, we can reciprocate this figure, and then so answer will be what? A alone can finish the whole work in 456 divided by 5 days, which is 91.2 days. So this equation types of question are little lengthy, but if you are using the steps wise, then I'm sure we can easily solve these kind of the questions in very less time. So let's discuss type 4 problem in time and work. So in time and work, type 4 problems is what, like A does some part of the work and B does some part of the work, or maybe C or D does some part of the work. But eventually, finally, they are part of work, A's part of work, B's part of work, or C's or part of work will become one. Let's understand from one example. Suppose that A can finish a work in 20 days. A alone can finish a work in 20 days. Suppose that you want to paint your house and you called A, and A says that I'll take 20 days to paint this house. And you also called B to take the quotation, then he said that I'll take 30 days to paint this house. So you have given the contract to A because A is saying that he can finish a work in 20 days. So A started the work, but after 5 days, due to some emergency, he has to basically leave the job. So he worked for 5 days, maybe he painted one of your room or something, and then he left the job. So what happens, like now you have to finish your work. So you called B and you asked B to finish the remaining work. So though work is going to finish, but some part of the work is done by A and some part of the work is done by B. So we can say that A's part of work and B's part of work will be equals to 1, because work we are going to finish 1. So in that example, we can say since A can finish a work alone in 20 days, but he worked 5 days. So 5 upon 20 means what? He does 1/4 of the work, right? Plus B can finish a work in 30 days, but we need to find out how many days he worked. So we'll write down x upon 30 and we'll add both their fraction of work. So 5 upon 20 plus x upon 30 is equals to 1, right? So let's make this, let's formulate this, right? So whenever this part of the work questions comes, so we always work in that way. So we can say that in the numerator we'll write down that how many days A works. So number of days A work divided by a total number of days A can finish the work, plus number of days B work divided by total number of days alone B can finish the work, plus if C or D is there, so we can keep on adding and is equals to 1. So A's part of work, B's part of work will be equals to 1. So these kind of the question we can easily solve by using this formula. Let's solve one question. Let's solve this question, book question, which question says that Alexander can finish a work alone in 90 days and Matthew alone can finish a work in 75 days. Right? You read the exact language of the question which is given here. So Alexander can finish a work in 90 days alone if Alexander works, and Matthew can finish a work in 75 days. But here in this question you can see the exact language of the question, that Alexander can finish a piece of work in 90 days and Matthew can do the same work in 75 days. Matthew worked for 50 days and left the job. In how many days Alexander alone can finish the remaining work? So we need to find out that how many days Alexander worked. So we know, as per the formula, number of days A worked divided by total number of days A can finish the work, plus number of days B worked divided by total number of days B alone can finish the work, is equals to 1. So here we'll write down the equation x upon 90. X is what? How many days Alexander is going to work. Divide by 90 is how many days Alexander can alone, how many days Alexander alone can finish the work, plus 50 upon 75. 50 is what? How many days Matthew worked, divided by 75 is how many days Matthew alone can finish the work. So final equation will be what? X upon 90 plus 50 upon 75 is equals to 1. So here in this question we can see that 50 upon 75 we can easily cancel by 25, so which will become 2 upon 3, and this 2 upon 3 will go at right hand side, so 1 minus 2 upon 3 will become 1 by 3. So the equation will be x upon 90 is equals to 1 by 3. So we'll calculate the value of x, which will come 30 days. So Alexander will take 30 days to finish this work. So this is the very simple method to solve these kind of the questions. We are discussing time and work problems, and in time and work, let's move to type 5 problem. So type 5 problems is the basically basically efficiency related problem. So in these kind of the problem, basically question will give you, maybe they will give you question in two format, right? Subtype A or subtype B, we can discuss in that way. So maybe question has two format, right? So one is what that they can say that if A is 2 times more efficient than B. So when I'm saying A is 2 times more efficient than B, so definitely A will finish faster. So time taken by A will be half the time taken by B. So we can understand this questions in that ratio. So if A is 2 times more efficient than B, if efficiency ratio is 2x is to x between A and B, then time taken will be T is to 2T. So time is inversely proportional to the efficiency. Similarly, it's a very common sense thing. Efficiency means what? If A is more efficient, then definitely A will finish work faster, right? Second is what? In these kind of the question, they may ask you the question in the percentage wise. They will say that A is, let's say, 20% more efficient than B or 40% more efficient than B. So definitely again A will finish the work faster. So B will take 20% more than whatever time A is taking. B will take 20% more time to finish the work, right? Or if we'll say that A will take A is 40% faster than B, or A is 40% more efficient than B. So B will take 140% of A's time to finish the work, right? So this is the basic concept of type 5 problem, efficiency types problem, right? Efficiency will transfer to the other side. So A is 20% more efficient or 30% more efficiency. So we will transfer the efficiency to the other side in the layman terms, or mathematical term we can say that efficiency is inversely proportional to their time taken. So A is faster, so definitely A will take. So just apply this simple logic. If A is more efficient or B is more efficient or C is more efficient, so person who is the most efficient, he will take less time to finish the work. Let's solve this type 5 problem, one problem. So Pipa is 40% more efficient than Ben. How much time they will take to complete a job working together, which Pipa alone could have done in 45 days? So in this problem, there are two things. There are two people, Pipa and Ben. So Pipa is 40% more efficient than Ben. So Pipa is 40% more efficient than Ben. So definitely Pipa will finish work faster. So Ben will take how much? 40%, whatever time Pipa is taking, more than the Pipa's time. So if Pipa is finishing in 48 days, So Ben will take 1.140% of 48, which is 1.4 into 48. So this kind of the way we will arrange the equations. So we know that now Pipa can finish a work in 48 days and Ben can finish a work in 1.4 into 48 days. So how many days together they will finish the work? We'll apply the simple basic type A problem. Now it will become a type A problem where we can say 1 upon, if we want to know that together they will finish the work, so which we use 1 upon A plus 1 upon B is equals to 1 upon X. So we'll just simply plug the values what we have derived. So 1 upon 48 plus 1 upon 1.4 into 48 is equals to 1 upon X. While solving this, finally we'll get the answer X is equals to 28. So this is the easiest way to solve this kind of the problem. So before you start solving the questions, you must derive A's time and B's time as per the given information given in the questions. Time and work, let's discuss type 6 problem, which is alternate days type. So suppose that if A is doing some work, right, and B is also doing some work, but these people, they are doing the same work alternatively, meaning that like suppose that they are painting a house. So one day A paints and then another day B paints, or C or D is also there. So they are doing alternately. This alternately basically combination can be a different format, like A, B, A, B, A, B, or A, B, A, B means what? First 2 days A work, then 1 day B work, then again 2 days A work and then B work, or 2 days A work and then 2 days B work, A, B, B, or C, C, right? So we can make the various combination for like alternate days time. So but the key is what? How to solve these kind of the questions. So there are the steps which we need to follow. That first thing is what we need to find out their cycle of the work, right? And so basically that one cycle of the work in how many days they are going to finish, right? So let's read this slide together with me. So what is the right way to solve these kind of the questions? So step number 1 is what? First we will find out that how many days they can finish one cycle of the work. Then step 2, now we will multiply the cycles, right? So we can find out how many cycles they can complete together, and we will find out the maximum number of cycles they can finish by multiplying the number, which will make the right hand side 1 or less than close to 1. So we are going to do either 1. If 1 is coming, then definitely work will be completed, but if, or maybe close to 1, which has to be less than close to 1. It cannot go beyond 1 because work cannot be more than 1. So definitely one work cannot be more than 1. So definitely we will find out close to 1 or less than close to 1. So and then step 4 will be what? We will find out the remaining work. So then if work is not completed, then we'll find minus from like 1, we are going to minus the whatever work is done, we'll minus that and we'll find out the remaining work. And then turn wise, now A's turn is come, to we are keep on subtracting that part of work, right? And then once the work will become 0, remaining work will become 0, then only we will say that question is solved. But if we are reaching some fraction of the work, so we will find out the fraction of work, the remaining fraction of work or part of work is still remaining, by using the part of remaining divided by 1 day work to find out the fraction of day. So we will, this is the easiest method to solve these alternate days kind of the problem. So let's understand this problem with one example. Like, let's read the question. Maverick alone can complete a work in 16 days and Bob alone can in 12 days. Starting with Maverick, they work on alternate days. The work will be completed in how many days, which we need to find out. So as we can see in this problem that Maverick alone can finish a work in 16 days and Bob alone can finish a work in 12 days. But what is happening here that these two people, Maverick and Bob, they are doing work alternatively. First one day Maverick basically does some work, and then next day Bob does some part of the work, right? So we know that in one day, since Maverick alone can finish a work in 16 days, so in one day Maverick how much work he can do? He can do only 1/16 of the work. Then next day Bob alone can finish a work in 12 days. So Bob alone can finish a work in one day how much? 1/12. So now cycle is what? 2 days cycle, because Maverick, Bob, Maverick, Bob, Maverick, Bob, this kind of cycle is there. So this is the 2 days cycle. So we'll write down in 2 days what is work is going to complete. Maverick was a 1 day work plus Bob's 1 day work. So in 2 days, how much work they are going to finish? So they are going to finish 2 days work will be what? 1 upon 16 plus 1 upon 12. So we can see the exact solution. So we can see that A's and B's, let's Maverick work is A and Bob's work is B. So A and B's 2 days work will be what? 1 upon 16 plus 1 upon 12, which will be 1 upon which will be 7 upon 48. So now we know that 2 days work is what? 7 upon 48. So which number we should multiply? We should multiply by 6, because 6 is the closest number which we can make it right hand side close to 1. So we'll multiply 6 both the side. So 2 days will become 12 days. So A and B's 12 days work will become 7 upon 48, 7 upon 45 and multiply by 6, which will become 48 upon 42 upon 48, which eventually will become 7 upon 8. So A and B's 12 days work is what? 7 upon 8. So here we can say that A and B's 12 days work is what? 7 upon 48. So now still, because work is not completed, still some work is remaining. So will be what? Will minus subtract 1 from the work is done. So remaining work will be what? 1 minus 7 upon 8, which is 1 upon 8. So remaining work is what? 1 upon 8 here. Then now next whose turn has come? Because till 12 days these people they have done the work, 7 upon 8 work they have done. So now whose turn has come? So now next day 13 days obviously A's turn will come. So A will do, and 1 day how much work he can finish? He can finish 1 upon 16 work. So what is remaining work? 1 upon 8 work is remaining. So A will do his part. A will do his part. So 1 upon 8 minus 1 upon 16. But still, if I say 1 upon 8 minus 1 upon 16, still 1 upon 16 work is still remaining. So now we have to finish the work. So now we'll call B, because next turn is B's turn. B can finish the 1 day work is what? 1 upon 12. And it is more than remaining work. Hence, we will find out the fraction of day. So how we'll find out the fraction of day? Part of remaining work done in days is what? 1 upon 16 divided by 1 upon 12, which is 3 upon 4 days. So B no need to finish the entire day, because he can finish a work in 1 day 1 upon 16, but he has to do only 1 upon 16 of the work. So since he has to do less work, whatever his capacity of 1 day work, so he will take only 3 upon 4 days to finish the remaining work. So in total, what will be our total then? So 12 days for cycle will taken, then A's turn, and the 3 upon 4 is the B's turn. So total 13 is to 3 by 4. So total it will take 13 is to 3 upon 4 days to finish the work. So this is quite interesting, like, so this is if you are using by step, so we are going to make this trickiest type of the question and very easy format, right? Only 2-3 things we have to be cautious. First is what? Make the cycle of the work, and then work on the remaining work or remaining part of the work. So that way, if we are using this method, so I'm sure this will be very much easier and will increase our accuracy to solve this kind of problems. So in time and work, let's discuss the type 7 problem, which is, we can say, salary type. So simply, like, suppose that A and B, they are doing some work and they got some total remuneration. So how they are going to divide the salary? So simply they will divide the salary as per their 1 day work ratio. Suppose that A can finish a work in M days and B can finish a work in N days. So their 1 day work will be what? So their 1 day work ratio will be what? 1 upon M is to 1 upon N. So definitely they will divide the salary in that ratio. So their ratio of their salary will be what? 1 upon M is to 1 upon N. So whatever their total salary will come, so we'll divide as per that ratio, and then we'll distribute the salary. Let's solve one problem then. In 65 days, William can complete a task, but Elizabeth can do the same task in 260 days. Both of them receive total of $500 for completing the assignment collectively. What is the William portion from the amount received? So as we can see the question, like that two people are there, William and Elizabeth. They have a different capacity to finish the work, right? And they got some total amount. So how we are going to divide the salary? We are going to divide the salary as per their capacity of their one day work. So as per the ratio of their one day work, we are going to distribute the salary. So as we know that their wages will be divided in the per day work ratio. Let's put in the formula 1 upon m is to 1 upon n, which is 1 upon 65 is to 1 upon 260, which comes 4:1 ratio. So definitely William will use a simple ratio and proportion formula to find out the amount. So as the total amount is given 500, so William will receive 4 upon 5, 4 upon sum of the ratio, which is 5, 4 upon 5 multiplied by 500. So William will receive $400 for his work. So this is one of the very easiest way to solve these kind of the problem. So whenever salary problems come or wages problem will come, so we'll divide as per their one day work ratio. If A, B is there, A, B, C, D is there, so we'll use the same formula to use their one day work. So in time and work, let's discuss type 8 problems, type number 8 basically. So type 8 problem is what we have, we can say we have given the name this problem X man and Y boys. So what is the situation? They will give you two different situations, and they will in the question they will ask you to solve the question from the two given situation and then find out the solution as per the third situation is given. Suppose that they will give you, let's say X and Y boys, X man and Y boys can finish the work in D days, and P and Q boys can finish the work in, let's say, W days. So now they will give the third situation where they will say alpha and beta boys are there, they will finish in how many days. So situation number 1 is given, situation number 2 is given, and situation number 3 will arise, and they will ask to solve the questions. So it's very simple question. Basically, if we are able to find out their one day work and then we equate, then we can easily get their, that man is equal to boys, so how many men we required, what is the, how many men we required to, let's say, one boy work is equal to how many men, or one man is equal to how many boys. So we are just going to paraphrase in the questions, and will convert everything in the either in man or everything either in the boys. So we can understand by this concept. Let's say if X man and Y boys can do a piece of work in D days, and P man and Q boys can do the same work in T days, then in how many days E man and F boy will finish the work? So solving, we can solve by the steps. So step number 1, what we are going to do, first we will find out their one day work for both. Then step 2, we will equate both the equations. Step 3, we will find out how, basically we will find out one man is equals to how many boys, right? And step number 4, paraphrase the equation by putting step 3 data. And step 5 will be what? We will take anyone and apply the unitary method with the problem questions. So if you are using these steps, so this question looks again like little lengthy questions. So we can easily solve with quickly apply with the quick steps and get the answers quickly. Let's solve one questions and to better understand this. So if 12 men and 16 boys can do a piece of work in 20 days, while 52 men and 96 boys can do the same work in 4 days, then time taken by 30 men and 40 boys in doing the same work will be what? So as per the question, we can see that that two different situations are given. X and boys were the different number of X and different number of Y's. Boys and men can finish the work in different number of days. So how we are going to do? So step number 1 is what? Very simple. We are going to first find out their one day work. In both the equation, we'll write down the two equation and we'll write down their one day work, and then we are going to equate the equation. So let's see the solution for this. So we can see that X man and Y boys can do in K days. So kx man and ky boys can finish the one day work. So now we reach to the one day work. So definitely as we need to find out the one day work, so we'll multiply k with the number of man and number of boys. So we'll find out kx man and ky boys can finish the work in one day, like that will come there one day work. Similarly, we'll find out p and q man can do a work in t days. So 2x man and ty boy can finish the work in one day. So now we are going to equate the equation. Kx man and ky boys can finish the work in one day, which will equals to tx man and ty boy can finish the work in one day. So we will get 1 man is equals to how many boys. So let's put in the equations. 12 man and 16 boys can do a piece of work in 20 days. So 240 man, 20 will multiply by 12 and 16 both. So we'll find out 240 man and 320 boys can do the work in one day. That will come there one day work. So if you want to finish the work in one day, so how many men and how many boys we required? We required 240 men and 320 boys. So we are finding the one day work if you want to finish the work in one day, so how many men and how many boys are required? Similarly, second part of the question says that 52 men and 96 boys can do the same work in 4 days. So similarly, if you want to finish the work in this situation in one day, so how many men and how many boys we required? Will multiply by 4 with both men and boys. So 52 multiplied by 4, which comes 208 men and 384 boys can do the work in one day. So in one day, how many men and how many boys we required? 208 men and 384 boys. So here you can see that we have reached two equation number 1 and equation number 2. So now what we are going to do, we are going to equate the equation. So we can say 240 men and 320 boys can do the work in one day is equals to 208 men and 384 boys can do the work in one day. Hence we'll reach 32 men is equals to 64 boys and 1 man is equals to 2 boys. So now what we are going to do, now let's make everything in the boys, like either we'll convert everything in the man or everything in the boys. So here we are just converting everything in the boys in the question to convert man into boys. So we know that in the question, now we are going to paraphrase the question. If 24 boys and 16 boys, so instead of man we are going to put boys everything. So if 24 boys and 16 boys can do a piece of work in 20 days, so 104 boys and 96 boys can do the same work in 4 days, then time taken by, now question basically. Question is we are going to put man again in the boys, 60 boys and 40 boys in doing the same work in how many days. So again, one more time we are going to paraphrase the question. So we know that 40 boys can do a piece of work in 20 days while 200 boys can do the same work in 4 days. The time taken by 100 days in doing the same type of work will be what? Now we will take anyone. So as per the unity method, 200 boys can take 4 days. So let's put in the formula M1 D1 T1 divided by W1 is equal to M2 D2 T2 divided by W2. So hence 100 boys will take 8 days to finish the work. So this is the very easiest method to solve this kind of it looks like a lengthy question, but if you are using these steps, if you are just converting everything in the one day work and then we are equating and then we are equating that how many men is equals to how many boys. So then we can easily find out and then we can apply the unity method and then we can solve the questions. So this is the very easiest method to solve these kind of the problem, right? This instead of man they can put boys, or maybe they can if they can make it question more and more complicated with putting man, woman and boys, or maybe some other way they can ask the question. But the method, if you understood the method, then you apply the same method and then you can solve any problem which they can make the various combination in this regard. So this, if you are using the steps, then it will become very much easier to solve this. So in time and work, type 9 problem is what? Different man and different days type. So suppose that M1 man can finish a work in D1 days and they are working T1 hours every day and they are going to finish W1 work. So we need to find out that M2 man will finish the work in how many days if they are working T2 hours every day and the work is W2. So we can understand this concept by this way, that if M1 man finish W1 work in D1 days working T1 time each day, and M2 man can finish W2 work in D2 days working T2 time each day, then let's put in the formula M1 D1 T1 divided by W1 will be equals to M2 D2 T2 divided by W2. So what important thing is what in these types of the question, if T1 and T2 is not given, or like they are taking the same time, so we'll not consider T1 T2, or W1 or W2 is not given, so we'll not consider W1 W2. So we can concise the formula as per our need. Only man and days is given, so we can even concise the formula M1 D1 is equal to M2 D2. Simple. So let's solve one problem in this type of the question. 14 engines of given type may generate a total of 700 units of product P in 16 days if they work at the same time and at the same pace. How many of these engines can create a total of 28,000 units of product P in 8 days if they all work at the same time at the same rate? So here in this question, like the engines are given, so we can say M1 is given, but M2 is being asked. D1 is given and D2 is also given, and W1 and W2 is also given, right? So their production is what W1 and W2. So we can, how we'll solve this problem? We can simply use the formula M1 D1, TV is not given. So we can simply use M1 D1 upon W1 is equals to M2 D2 into W2. So let's put in the formula and then solve this. So M1 is equal to 14, M2 is what? Let's take K. W1 is given 7,000 and W2 is what? 28,000. D1 is what? 16 and D2 is what? 8. We'll put the formula and then we can get the answer 112. So if we are using this simple method, so we can easily solve this a different man and different days types of problem. Only thing is that we need to remember the formula, or we can derive the formula only. This is the only a unitary method, right? So we are equating both the side and we are deriving the formula. So formula is what? Remember M1 D1 T1 divided by W1 is equals to M2 D2 T2 divided by W2. In time and work, let's discuss type 10 problem, which is we can say food remaining type. These problems generally, they will say that for there are some arrangement of the food or maybe some other things. So and the situation is changing. Suppose that in a hostel some boys they are living and the food is available for few days, right? But what is happening, after a few days some more students they join or they go. So definitely the number of days, if number of students more are coming, then definitely food will not remain that those earlier days, it will finish earlier. Or if some student they are leaving the hostel, then definitely food will remain for more number of days. So this is the typical types of the problem. But important thing is what here, as we have discussed and that as we have discussed earlier, that M1 D1 T1 divided by W1 is equals to M2 D2 T2 divided by W2. The formula will remain the same, but cautiously and intelligently we need to change what is our new M1, what is new D1, what is new M2 and what is new D2 as per the situation arising. So we can say that we can understand the concept. If food is available for A days for M1 man at a certain place and after B days M2 man join, then the remaining food will serve total man for required time will be what? We'll use our original formula M1 D1 T1 divided by W1 is equals to M2 D2 T2 divided by W2. Now we are going to do some changes in the formula. Now as per the, we'll use the steps. Step 1, D1 is changed as B1 boy food is already B1 days. Now step number 1, now D1 is changed as B days food is already consumed, B1 days is already consumed. So we'll start counting after B days. So D1 is equal to what? A minus B days. And step 2 is what? As M2 new members are coming, so M2 will become M2 is equal to M1 plus M2. If M2 people are leaving, then M2 will become M1 minus M2. So we can simply use the formula m1 into a minus b is equals to m1 plus m2 into k. K is what? Number of days, how many days food will remain. Let's better understand these problems, and let's solve one problem. In a hostel, food is available for 400 students for 100 days, but after 20 days, 240 more students have come, then food will last for how many days? So as we can see in the problem that for 400 people, for 400 boys, food is available for 100 days. But what is happening? What is happening after 20 days, 240 more students they have come. So what is happening that for M1 is what really, if everything is normal, that for 400 students, food is available for 400 students is what? 400 days. But now after 20 days, situation is changing. So definitely 20 days food they have consumed properly. So right now, as per the current situation scenario, for 400 students, 80 days food is remaining. For 400 students, 80 days food is available. They can we can easily feed them properly, normally. But now situation is changing here. What is happening here? 240 more students have joined. So now number of students are not 400, number of students are 640. So we need to find out for 640 students how many days food will be there. So we can simply solve this by using the method. M1 here is what? 400, M2 is what? 240. So D1 is what? 80, D2 is what? K. So let's put in the formula M1 into A minus B is equals to M1 plus M2 into K. So 400 into 80 is equal to 640 into K. So finally we'll get K is equal to 50. So food, earlier it was sufficient for 80 days, but now food will sufficient only for 50 days because 240 more people have joined. So if you are using these steps, so it will become very much easier to solve these kind of the questions.